Hello and welcome to this LangChain tutorial. So in this video, we'll discuss what are vector stores and support for vector stores in LangChain, along with some examples of storing data in these vector stores. So we have already seen in previous chapter how you can convert your documents into high dimensional vectors, which are embeddings, and that actually represent the semantic meaning of the text. So now the next step is where to store these embeddings so that you can later retrieve the relevant documents by doing the semantic search, right? Which means getting those portions of the document that are relevant to the asked query. So for that, you will use vector stores. So what actually are vector stores? Vector stores are special kind of databases actually that can store embeddings. So here is one workflow that shows the steps from how you load the document to split the document to create embedding to storing it in vector store. So these are the steps you do in your LangChain workflow from loading the document to storing it in vector store, which involves all these steps, correct? So in traditional databases, in a traditional database, what will you do? You'll do a search on exact keyword, right? That's what happens with traditional databases, and that's how a vector store differ. With vector stores, actually, you do a semantic search, correct? So you can retrieve information based on the similarity of the document where that semantic meaning come into picture. So these points like what is semantic meaning, what is semantic or vector space, and what actually is semantic proximity, all that were discussed in detail in the previous video. So have a look if any doubt about these points. So you can go through that video. We have already discussed all these points. So here, coming back to vector store. So if we have to understand how vector stores work actually. So when you query these vector databases, right? Once you have stored the databases and you are trying to query these vector databases, your query is also converted into a high dimensional vector. So that is the point you have to remember, that your query is also converted into a high dimensional vector. And then these vector stores use one of the metrics, right, to calculate mathematical distances, that also discussed in previous video, how actually it LLM decides which are similar. So for that you use either cosine similarity or Euclidean distance or such matrix. So using that, vector store will compare your query, which is already converted into high dimensional vector, and try to find the vectors which are closest to this query vector, right? So that's how your similarity search happens actually. So here is a flow again which describes the task in detail. So user query, which is converted into embedding, then you do a similarity search where you compare your queries vector with the stored vector in the DB, and you try to get the vectors which are similar to this query. All right. So there is also indexing in vector store, just like traditional DBs, which makes retrieval of data more efficient, right? That's why you do the indexing. So when you do the indexing, you don't need to scan every vector one by one. So that makes retrieval quite fast, correct? So here are some of the algorithms used for indexing. So there is tree-based structure. So with tree-based structure, what you can do is um, DB can only go to those branches that are relevant to the query, which reduces, of course, which it will reduce the number of comparisons, right? Because it will eliminate the entire branch of the tree that is irrelevant to the query. There is also clustering, where you group vectors into clusters. Then you look for only those clusters which are relevant to your query. There is also graph-based approach, where you connect vectors in a graph-like data structure and look for nearest neighbor by traversing these edges. So that is how indexing is done. Just giving a heads up. This is already done in the architecture or whatever vector store you are using, right? There it is already there, so you don't have to do anything, just giving an idea about this indexing. So now coming to some of the commonly used vector stores. So there is Chroma, which is a lightweight open source vector DB with local persistence. That means you can download this vector store and persist data in your own system. It also provides easy LangChain integration. Then there is Pinecone, which is a fully managed cloud vector database. That means it is highly scalable and you can create production ready similarity searches with this. There is BV8, which is again open source and cloud native. There is Milvus, which is cloud native. There is Fice by Facebook, that is also used locally most oftenly. Then there is Quadrant, which is again mostly cloud native and open source. So if you want local development, then you will go with Chroma or Fice just to create a quick prototype, but not suitable for a production ready RAG type of workflow. Correct. So for your own practice, you can use these DVs. If you want to create a proper scalable cloud deployment, then you have to go with Pinecone, VV8, and such vector stores. So in LangChain, you have support for these vector stores, and as for everything else, LangChain provides a unified interface for integrated with many different vector stores. Whatever you use, you can use vector store you can use the same common methods, which is you can use add underscore document to add the document to the store, delete to remove store document by ID, and you can do similarity search by querying for semantically similar documents. So LangChain provides support for many vector stores. There is in-memory vector store support for Chroma, you have support, and for Fice, PG vector store, which is an extension of PostgreSQL. There is MongoDB Atlas vector search, which is a vector store by MongoDB. There is a Pinecone vector store, and many more are there. So what you need to do is just import the relevant package in LangChain, like LangChain underscore Chroma for Chroma, LangChain underscore Pinecone for Pinecone DB, and so on. So that's some theory about vector store. Coming to the example, so we'll try to do a full-fledged example where we go through all the steps of loading and splitting the document, creating embeddings, and then storing it in. First, we'll use Chroma vector store. So we'll store it in Chroma vector store. Then we'll try to use some other DB, maybe Pinecone. So for that, first thing you have to go to the requirements.txt and add these two packages, LangChain underscore Chroma and LangChain underscore Pinecone. Then you have to run pip install -r requirements.txt. So I've already done that. So that I have these packages installed. That is first thing. Then I've created a folder, relate vector stores. That's where I'll create the files for this vector store example. Okay, so now once we have imported the packages, we have to create the file. So first file I'll create within this L8 vector stores, which will be util.py. So that's where I'll store all the utility functions like loading, splitting, getting the embedding model instance, all that I can do here. So these will be the imports here, right? Related imports, PyPDF and directory loader and a recursive character text splitter and Google generative AI embeddings. So first thing, let's say, is load underscore documents function where I load the document. So I'll get some path here, directory path. Using that, I will load the document where I'll use this directory loader. Directory loader, there I'll first thing the path, then which kind of files I want to load, that I have to give. So for that, let's say all the PDFs within that directory. and the class I want to use for loading is PyPDF loader, right? So these will be my directory path, blob equal to this path, and loader class, right? So that will be my loader. So once I have this directory loader, using that I can load the document. So documents equal to this loader dot load method I'll call, and I will return these documents. So that is what this function will do. Then I'll have another function for splitting this. So let's call it create underscore splits, which will get this document and then split it. Documents. Using that, I'll create the splits. So for that, what I have used is recursive character text splitter. First thing is this. In that, I have to give chunk underscore size. I'll use 1000 and overlap of 200. So 1000 character split, overlap is 200 character. That is my splitter instance. Text splitter equal to recursive character text splitter. Then using that I can split the document. So that will give me chunks. Text chunks equal to text underscore splitter dot split. Since we are splitting a document, so I'll use documents. In that I'll pass this documents. That will give me splittings. So then I can return this also text underscore chunks. Third function I can get is create is this get embedding, which embedding model I am using, that I can pass along. All right, so here you have to use embedding model, which what I'm using is Gemini embedding 2 preview. So embedding model, that will return the embedding. So this is a class where I have all the utility functions, right? So keeping them separate, that's how you should do. Then I'll create another class for keeping all the DB related work. All right, or let's call it ChromaDB underscore util.py. So here I will get all the vector store related functionality. So I'll import Chroma. Then from this class, I'm importing all the functions also because I'll use them here. So first thing, I have to create an instance of my Chroma store. So I can create that def get underscore Chroma store. That what you do is actually to create a Chroma store, you have to use this Chroma. In that you pass, first thing is collection underscore name. So table name, you can say, where you will store all your data. So collection name I can give as it's a data underscore collection. All right, collection name is there. Then you have to give the embedding which you are going to use. All right, so embedding underscore function. So for that, I have to create that instance or get that instance from my utility. Embedding function equal to embeddings equal to, I can use this method to get my model, right? I've already created in that utility. So using that, I can get my embeddings. That's the second thing. Then what you need is a where you are actually keeping your data. So persist underscore directory. So if I do in the current project itself, I want to keep some name. So persist underscore directory, I can give as a Chroma proj underscore db. So Chroma project I'm creating, and for that is I have a db. That is the name. In that it will create this table where it will keep the embeddings. So this is my Chroma store. I have to give some instance here. So let's say vector underscore store equal to this. That is I can return. All right. So wherever I need, I can use this function to return a vector store. So if you want, you can create this as a singleton kind of. So what I can do is vector underscore store equal to none. So initially it is none. Then what I can do, I want this same instance. So global vector underscore vector underscore store. Then I can check if this vector store is none. If it is none, then I can do all this. Correct. So I can create one instance in the beginning as none. Then I'm using global keyword to tell that this is not a local another keyword variable. I'm using the same variable vector store. Then I check if it is none. Then you do all that. Otherwise, you return the same instance which is already created. Then I can create one more function to load data. So that will be my main function where I'll call all the other functions. So here I'll get my documents equal to, for that I'll call this load underscore documents, and I'll pass the directory where my files are. So I've created a directory resources as I've already done in the previous chapters. Here I have some PDFs. That is what I want to store. So I can give as dot slash resources. So directory will load all the PDFs within that using that glob. Now I have document. So other thing I can do is create splits from this documents, that let's name again text underscore chunks. So I'll get my splits. So now I have my text underscore chunks. Then I can call this function to get a vector underscore store equal to get chroma store, and that's where I will store these chunks. So for that I'll call the add document, which is given by LangChain add underscore documents, and that I will store pass all the text underscore chunks. So that's how I can get data in my vector store. What I'll do is I will run this file once already so that I have my data loaded. Then I'll create my another file. So what we can do is run this file. Python dot slash sl8, and what else is there in that? I have this ChromaDB.py. That's what I want to run. All right. So what I'm doing is I'm running this. So all this process, right? Document loading, splitting, and my storing into database. So some problem, get embedding model. Okay. So these functions from there, right? Here also same mistake, then I can put embedding underscore model. Oh, then the often done mistake. Dot env dot env, and that I have the API key. Okay, so one problem I got is Google Generative AI embeddings, which I was trying to use for that quota is already over. So free tier is a very limited quota. So I already exhausted that. So what I did is I started using Olama embedding. So I made a small change in my util.py file. I've imported Olama embeddings, and that's what I'm returning now in get underscore embedding underscore model. And model I'm using is nomic embed text. Okay, I have a local Olama setup also, so I'm using that now. That was the only change. It is getting these functions, so here we don't need to change anything. With that, I ran it again, and it has created, if you see, I have given that, right, chroma underscore proj underscore db in current project itself. So it has created this directory. Within that, it has created some embeddings. How good these are, for that we have to now create another class and check, right? So what we have done is document loading, splitting, and embedding and storing that in db. Now we'll create another file and try to query this vector store to see what we get. Okay, so I'll create another file here. I'll name it chroma app.py, where I'll query this vector store now. So I need some imports. I need chroma, and from this chroma db util, from that I will need to get this chroma store. So using that, I will get an instance. Let's name it vector store. Get chroma store. So now I have my chroma store. Let's create a function, name it do search, where I'll pass some query, and then I'll do a similarity search on my vector store. So vector store. So I'll call this similarity underscore search method on that, which is again, as we saw through LangChain, you have these methods and add, document, delete, and similarity search. So I'm calling that. In that, what I have to pass is this query. Pass it as a named parameter query, and I can also pass another k, tell how many documents I want it to return. If I say 3, it will return the 3 similar documents. If I give 2, it will return 2, 5, then it will return 5. So number of results it will return. That's what I'm getting. 2k. So that will be my result. Then I want to print that result here just to see. Okay, so for I want to give some index also for I. This enumerate, then I use enumerate this result. So I print result I plus 1 result and then from this rest I have to get the page underscore content. So it has page content and page metadata. So using that I can get the content. Let's not print everything. I'll print first 500 characters, then slash n. Okay, so that will be my do search method. Now I can query it. So let's query it 2-3 times in one shot itself. So again, my document is related to medical insurance. So I'm asking some questions based on that PDF which I have loaded here. What is the waiting period for the pre-existing diseases? What is the condition for getting cumulative bonus? And what are the co-pay rules? All right, so let's say I run it and check how effective it is. Is in L8. Right. So within that, Chroma app name itself is wrong. Underscore utilities, not util. Okay, so there were a couple of mistakes. This search spelling was wrong, and also in this print here also you need curly braces. Rest dot page underscore content. So their curly braces were missing. So after that, fixing these two things when I ran the program. So this is for first query. All right, what is the waiting period for the pre-existing diseases? So this query will come here. From there, it will go to the similarity search. Then vector store, as we have done here, it has embedding also, right? When we create instance of Chroma, using that, it will create embeddings for the query also. Then it will do the similarity search, looking for the vectors which are in the same space. That's what you will get as a result. And there is R k was 3, right? So we'll get 3 results for the first query: result 1, result 2, and result 3, where it looks like it got it right and it is giving some waiting period duration for some of the diseases, right? Then we have another query here which was about cumulative bonus. So existing cumulative. So okay, I'm just printing 500 characters. So it is talking something about that. So looks like that is also okay. Then we have about copay rules, which starts from here. Um, that doesn't look right, at least in whatever is here. Okay, so this one I don't know what is there in the document. So maybe we have to check that, but this doesn't look right. At least search for that. It is not able to get any proper chunk of that related to what is the query. Other two, it is looks like it is able to fetch something similar. So that is how you can do a similarity search after storing data in vector DB. All right, so that is done here. How you store. So we have done all the steps from loading, splitting, embedding, and storing, and then doing a search on that particular vector store. So that is about how you can do this vector store thing with the Chroma. So let's see how we can do the same thing with Pinecone, but that will require some configuration. So let's first do that. So if you want to use Pinecone vector store, then first thing you have to search for Pinecone, go to that site. Once you are here, log in with your ID. You have to create and sign up, all that. Once you are done with that formality, first time when you log in, it will show you an API key as soon as you come here. So take that API key, copy that, and put it in your Python project. If you have a .env file, put there with this key pinecone underscore API underscore key equal to whatever is the API key given by the Pinecone. So that is one thing. Then it also will show you by default one project. So project name also is default. You can use it as it is. And in free tier, you can create only one project and one index. So that is why you can't create. If you want to delete it, then in action, you can delete it and create with some name. I will go with this default only. If you click on this, then it will ask you to create your first index. And as it is showing here itself, you'll have to create that index because that is what it will use to store and search vector embedding for your applications. So that is something you have to do. So give some name. I am giving test. Then here in configuration, just go at the end. Sorry, test. Then I'll come here. I'm going with manual configuration. So vector type I'll keep as dense. Dimension I'm giving as 768 because I think with nomic embed text, which I'm using with Olama embedding, I'm using nomic embed text that has these dimensions, if I'm not wrong. So I'll go with that and create an index. So remember your API key and then this index test, which you have to create and ensure that it is initialized. So right now there are no records. Now you can go and start your coding. Then you can verify once you have actually come to the point where you have loaded the document, done the splitting, embeddings and stored it. Then you can come here after running that to verify that your data is actually stored in this Pinecone vector store. If you are done with the setup of Pinecone, so we are going towards Pinecone now, then first thing ensure that you have this package installed, LangChain underscore Pinecone, and ensure that you have that Pinecone underscore API key set in your .env. Then it is almost similar code wise, so I've already created those files. So what we did for Chroma, it is almost similar. So we are still importing three functions from our own util for loading and splitting and embedding. That you will do. Then now you are importing Pinecone vector store and also Pinecone. Then since we need API key for Pinecone also, so we'll do this .env, load it. So for using Pinecone, actually you have to configure the Pinecone client. So that is one thing you have to do. That involves using the API key to initialize the Pinecone object or client. So Pinecone, there you will pass API key by getting it from the environment. Another thing, you have to set the index, pc.index on that Pinecone client. Ensure that this index name is same as what you have already set in Pinecone vector store on the cloud. Once that is done, then it is same thing. You get your embedding model. You initialize Pinecone vector store. Here you will send the index, this index, and embedding. Then you return the vector store. Then you have another function, load data, where you will load the document, split it, get this vector store, and add the documents using this splits. So this class you can run initially itself, and if it runs successfully, then you can also check there in your setup of vector store, Pinecone vector store. So you should be able to see the data stored there, whatever you are loading, right? So that you will be able to see what is the name, Pinecone DB util. So you have to run this so that data is uploaded there. So if you want to verify whether your documents are actually uploaded here or not in the cloud vector store, Pine vector store, for that you can come to your Pinecone site with you have to log in with your login ID. There, if you go to indexes, what you have created test, right? Click here, you should be able to see um, by default it shows top 10 document. That is enough. So if you see here, it has some documents or chunk of that stored, right? So first chunk where you have all this data, which is metadata for that particular document with text. So that's how you can just verify that what you have done is actually storing the data or not. With that, we come to another file, Pinecone app, where we actually use it. So here, again, you have to import this get Pinecone store. So using that, you create a vector store, then you do a search. So that is the function do search, where you will call the similarity underscore search with query and how many results you need, that you will give with a. Then we are just printing it. Then we have the same queries. So flow is similar using this similarity search. First you will get the vector store. So for that it will come here, vector store. Here it knows what is the embedding it has to use. So I'm using the same Olama embedding with the nomic embed text. So your query will also be converted into a dense vector. Then it will see or look up for the vectors which are similar to your query by doing a semantic search. Okay. So if I run this one, Pinecone app.py. Alright, so I got some document based on similarity search. So I have 3 queries and each query will give me 3 results. So first query is what is the waiting period. So again, if you see, it has given me some duration, what is the waiting period time for which disease. So looks like it is getting me correct documents or correct chunks within the whole PDF which are similar to my query. Then another query which is about conditions for cumulative bonus. So again, I see noted cumulatively for you. Some cumulative is there. Not sure it is correct or not, but yeah, it is getting me some relevant documents. Then I have about the copay rules. So starts here. Again, for copay rules, I think there is nothing there in the document, or it is with some other name. Don't think these documents with Pinecone also, it is very similar to query. Anyway, that you have to check in the PDF itself. So that's how we can use Pinecone vector store, and with that we have seen examples of both ChromaDB and with Pinecone vector store, how you can store data and how you can do a similarity search on that vector store to get the similar documents. So that's all about the vector stores. Thanks for watching the video. Please don't forget to like and subscribe.